All right, we're in section 20.3, motional EMF. Now, before we get into this figure here, let's just think about a charge in the magnetic field, and let's think about a right-hand rule. Uh, of course, if we have a charged positive particle, I'm going to use the magnetic field that's presented here. Now, to me, it's into the screen, so I'm going to point my fingers into the screen, and the velocity is in this direction. So on a positive charge, the force would be upward, but on a negative charge, it would be downward. And so if we go to the figure now, we see that there's an electric field as this bar moves to my right. There's a force, this little Fm, there's the force on an electron, and it forces the electrons down to the bottom of the bar. And as and that force is QVB. The force on the magnetic force on the electron would be QVB. Now, after a while, you've got some positive the electrons down here, and you're left with protons up at the top, and so there's an electric field. If you have positives and negatives, you're going to get an electric field. Once things come to an equilibrium, you're going to have QE equals QVB, or E equals VB. The electric field equals VB. Delta V is going to be the E times the induced voltage. Delta V is going to equal the E times the length, that electric field times the length, which is BLV. Now, the magnetic force opposes the motion, and a counterclockwise current is induced in the loop. Now, let's think of this in terms of Lorenz's law. As the bar moves, you have a growing magnetic field. Lenz's law says it wants to oppose the magnetic field, so it's going to put a current downward through the resistor, which is also in this direction through the bottom bar. So we can see that the current is in this direction. E equals BLV. So the changing flux, delta phi B, is equal to the magnetic field, times the area, and the area is equal to L delta X. So E is equal to the changing magnetic field divided by a unit of time, equals BL delta X over delta T. Well, what is delta X over delta T? That's velocity. Distance over time is equal to velocity. So the current is equal to E over R equals BLV over R, the resistance. And that's it for that. Next one we'll do is generators.